Hello everyone, welcome to this video. In this video we'll be solving this question which states that suppose a group contains two elements A and B such that the order of the element A is 4 and the order of the element B is given to be 2, right? And we are also given this condition that A cube B is equal to BA. Then we have to find what is the order of AB. So here because we are talking about the order of an element, so let's recall the definition. We know order of an element, suppose we are taking the element Y from our group G, right? So within this group we are assuming the group operation as multiplication. If nothing is given to us, we are taking the group operation as multiplication. So you can assume multiplication to be the default operation, correct? So we are taking Y and we wanted to calculate its order. Its order would be the positive integer which we are calling by n, such that when you take y raised to power n, you get e, which is the identity of the group, right? This is the definition of order of a group. Now here in this case what we are given? We are given that the order of A is equal to 4. What does it mean? It means that when you take A raised to power 4, you get identity, right? Let's call this as equation 1. We are given the order of B is equal to 2. What does it mean? It means that when you take B raised to power 2, you would get identity. Let's mark this as equation 3, right? Now we wanted to calculate the order of AB, right? So for that we are looking for some positive integer for smallest positive integer such that you have AB raised to power n is equal to identity, correct? So let's use this condition which is given to us. We are given this condition A cube B is equal to BA. Now here A cube B is equal to BA, right? This is the one that is given to us. Yes. Now here we are given this thing. Now you have to see how we can make use of these conditions here in order to obtain an expression of this kind. So we can it is very obvious from here that you can use this relation whenever you have A raised to power 4 and B raised to power 2 here. So what we can do here, we can consider we can consider A cube B is equal to BA. Now what we can do, we can pre-multiply both sides with, right? We can pre-multiply with A. Why? Because we wanted to make it as A raised to power 4. And what we can do, we can post multiply it with B. We can post multiply with the B to make the B power 2, right? So that here you would have A cube, here you would have BB. This is equal to AB, correct? So you can write this as A raised to power 4, B raised to power 2. This is equal to, now you can use brackets here, AB. Now what is A raised to power 2? It is equal to E according to equation 1. And what is B raised to power 2? It is also equal to E according to equation 1. And you can write it as AB whole square, right? Now this we obtained using 1 and 2. So using 1 and 2 you obtain this, you know, identity into identity is identity. So you obtain AB square is equal to identity. Now can you see the similarity between this and this, right? So therefore in this case we have AB square is equal to E, and clearly AB is not equal to identity. Why? Because A and B, they are not the inverses of each other, correct? And moreover they have the orders 4 and 2. So because B inverse is what? B inverse is just B, because we are given B square is equal to identity. So this is not equal to E, as B inverse is not equal to A, as B inverse is equal to B, because we are given that B square is equal to E, correct? So therefore they both cannot be the inverses of each other. So therefore we cannot have this. So therefore we obtain, 2 is the smallest positive. Why this step was required? Because we wanted to prove it as smallest positive integer of such kind, such that we obtain AB raised to power 2 as equal to identity. Hence, the order of AB is equal to 2. This is the answer. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.